Alright, so good everybody. I welcome you all to Noble Team YouTube channel, and my name is Noble, CEO and founder of Noble Team. And today's class we are going to be looking into vibration in strings or spring and pipe. Okay, good. And the aspects under sound waves. These are topics students find it difficult, and if you are watching this video is not only for JAMB. This video are meant for JAMB students, YX students, NECO students, GCE students, post-UTME students, and even A-level students. For students that are in 100 level, because you still do this particular thing that I'm about to teach you today under sound waves. Okay, now before we move on, I would advise you to get your writing materials ready, get your calculator ready, because we are going to be solving a whole lot of questions under these sound waves. Okay, good. And if you have not subscribed to our YouTube channel, do help to subscribe, like this video, and share it out to your friends so they can benefit. Now, without wasting much of our time, let's look into the deal we have on the board. Okay, so make sure that any point I'm giving out, you are writing it down. Good. Now, when we talk about sound wave, we can't just come and dive into vibration without understanding what sound waves is all about. Okay, now when you talk about sound wave, they say that sound waves is produced by a vibrating body. Okay, sound wave is being produced by a vibrating body. Now, what am I trying to say in essence? For example, if you want to play your guitar, you have to vibrate the spring. You have to vibrate the strings here. Okay, good. So that is why they say sound waves is being produced by a vibrating body. Now, moving on, when you talk about sound wave, we consider two things. The first one is we talk about overtone. Okay, let me start with harmonics. Okay, we talk about the first one, which is what? Harmonic and overtone. Now let's start by explaining what harmonic is all about. Now when you talk about harmonic, make sure you are writing. Okay, harmonics, or harmonics. Now harmonics are frequencies that are multiples of the fundamental frequency. Okay, they are multiples of the fundamental frequency. Frequencies. Okay, good. Frequencies. So I hope you can see this. Okay, do you understand why I just explained that harmonics are frequency that are multiples of the fundamental frequency? Now, what am I trying to say in essence? Now, before that, take notes. Okay, notes that the first harmonic is equal to the first fundamental frequency. Now, what am I trying to say? That if we have the first harmonic, which is what? Harmonic. So we can say it is what? The first fundamental frequency. Now, I hope you all know that it is wrong for me to come and write 1F. Okay, it's wrong, but it is correct for me to write what? 2F. Okay, now this F degree is what we call the fundamental frequency. Okay, good. Now let's move. We have the second harmonic. We can say that the second harmonic is what? The second fundamental frequency. The third harmonic is what? The third fundamental frequency. I'm going to explain this when we move into pipe. Let me leave this for now. Okay, good. Now you can also say that fourth harmonic is equal to the fourth fundamental frequency, etc. You can do it to 100. Okay, good. You understood to this part. Now let's move into overtone. Now overtone, when they say overtone, now overtone is the next higher level of a fundamental frequency. Is the next higher frequency, next higher level of a fundamental frequency. Or you can say it is the next higher level of multiples of fundamental frequencies. This will now change to what? Frequencies. Okay, good. Now what am I trying to say in excess? For example, listen, I have 0/2. Listen, I have 0/2. I have 0. This is 0/2. So the next higher level is going to be what? 1 harmonic. Or I will say first harmonic. I have 1/2. If I have 1/2, my harmonic is going to be what? The higher level of 1 is what? 2, which is second harmonic. I have 2/2. The next higher level is going to be what? 3/2. Third harmonic, sorry. I hope you understand what I'm trying to explain. Good. Now I have 3/2. The next is going to be what? Fourth harmonic. So I can either choose to do, let me do fourth. Okay? 4/2. 4/2 is what? Fifth harmonic. etc. Okay, good. This is what this point is trying to explain. Next higher level. Okay, good. So I've explained overtone and explained harmonic for you. Now let's move into vibration in pipe. Okay, vibration in pipe. Vibration. Okay, let me not write the vibration now. Let me clear this. Okay, vibration in pipe. Now when you talk about vibration in pipe, we have two types of pipe. We have the open pipe. We have the open pipe, and the closed pipe. Okay, good. We have the open pipe and the closed pipe. So we are starting first with the open pipe. And I need you to pay maximum attention because this is where the real deal is. Okay? Now, open pipe. Open pipe. We have open pipe. Opened pipe. Now, when you talk about open pipe, right? Number one, open pipe is a type of pipe where both ends are opened. Both ends are opened. Okay, good. And point two, in open pipe, the open ends are called the antinode. The opened end are called the antinode. Let's take note of this. Okay, good. Now, what is an antinode? Antinode is the maximum displacement of a particle or air. Okay, it is the maximum displacement of particle or air. Okay, good. Now, in open pipe, but before that, let me explain this with a diagram. Okay, good. All I need from you is pay maximum attention, avoiding anything like distraction. Now, remember, both ends are open. This is the key word. In open pipe, both ends are opened. Now, I have a pipe. Okay, listen. I have a pipe, so I think this is correct. Good. They said both ends are opened. Both ends are opened. Okay, both ends are opened. Good. Remember, I said I'm going to explain fundamental frequency when we move into this vibration in pipe. Now, both ends are opened here. Listen. This is my antinode. This is my antinode and this is my node. Now, what is a node? Node is a point where there is no displacement. Is there anything like displacement? No. Is there anything like displacement? Yes. Do you understand? Now, this is what I'm trying to explain. The opened end are called the antinode. Are you understanding what I'm trying to explain? Now, also note that this can also be drawn like this. Also note that this can also be drawn like this. So I can also choose to draw it like this. Okay? I can also choose to draw it like this. Okay, this is my antinode and this is my node. I can also choose to draw it anyhow that you wish to draw it. Okay, good. Now let's move into the real deal. Remember that in waves we have something like this. In wave we have something like this. Okay, we have something like this. Okay, good. And if I want to represent this like this, now this particular thing I have, I want to draw an open pipe. I can choose to draw it like this and like this. Okay, good. Listen, I'm trying to explain something. Now, this is like saying that here, full of discs now. Listen, that full of discs is what? 1 over lambda over 2. Do you understand? Because if I cut discs now, this place is lambda over 4, this place is lambda over 4. Lambda over 4 plus lambda over 4 will give us what? Lambda over 2. Okay, good. And this is not even up to lambda, a full lambda over 2. Now this is what? Full lambda. This is a quarter lambda, and it's like saying lambda over what? 4. Okay, lambda over 4. So this is what I'm trying to explain. Do you understand? Now let me give you another thing, because we need it here when we want to derive the formula. Now imagine I have this. Okay, listen, imagine I have this, okay, and I have this. Okay, let me choose to stop here. So this is what? If I bring this down, this half. So this place is what? Lambda over 4. This place is lambda over 4. Lambda over 4. Lambda over 4 plus lambda over 4 will give me what? Here is what? Lambda over 2. So here also is what? Lambda over 2. And here also is lambda over 2. So imagine that this particular point now did not reach here. Maybe stopped here. This is going to be what? Lambda over 4. Okay, good. I hope you understand this point. Good. Now let me clean this plate so we can move into this deal. This is the guy that we have business. Using this diagram, this is an open pipe. Okay, good. And in an open pipe, I explained something previously before I wipe this board. Okay, so if you trace this now, if you trace this, and if you trace this, is this up? I've traced this now. Okay, I've traced this. Now, according to what I explained in what I just wiped up, is this a quarter or a half length? I want you to understand something. So This is what? This is quarter and this is quarter. Now that is why you will see that antinode is equal to what? Lambda over 4. This is very, very important. Lambda antinode is equal to lambda over 4. Okay, good. Antinode is equal to lambda over 4. When we reach into node, I'm going to give you the value of it. This is very, very important because they can ask you this kind of question. What is the value of antinode? Is what? Lambda over 4. Now, since they are open pipe, this is open, this is open. Now, getting this, remember I'm trying to explain this particular diagram before I move into fundamental frequency. Okay? So this is what? Lambda over 4 and lambda over 4. And when you add it, you are going to be having that it is what? But before that, this is it. This is your length too. So basically means that your length is equal to what? Lambda over what? 2. Because lambda over 4 plus lambda over 4. This is lambda over 4. This is lambda over 4. And you give us what? Lambda over 2. Do you understand? Now let's move. Now, in open pipe, the fundamental frequency is what? F degree is equal to what? V over 2L. Let's take note of this. Okay, good. Now, what is fundamental frequency? Now, pay maximum attention. Fundamental frequency is the simplest loop or mode of vibration. Is the simplest loop or mode of vibration. Now, this is the simplest loop or mode of vibration in an open pipe. Should I prove it? Okay, now let's move. So I've said that my L is equal to this lambda over 2, and we all understood how we got lambda over 2, which is the length of this to this is lambda over 2. Okay, good. Now, since fundamental frequency say it is the simplest mode of vibration, the simplest mode of vibration of an open pipe is this. So since my L is equal to lambda over 2, I can simply say that lambda is equal to what? 2L. So I'll call this equation 1. Okay, good. Now, the general form of equation of a wave say that V is equal to what? Lambda multiplied by frequency. V is equal to lambda, or let me say lambda multiplied by frequency. Okay, good. Now, I can simply say that frequency is equal to the fundamental frequency. Do you understand? Now, from here, I can say that my frequency is equal to what? Velocity over lambda. I can call this what? Equation 2. Now, since from this, my lambda is what? 2L. You can see it. I've proven it. Okay, good. That this is the simplest mode of vibration of an open pipe. Do you understand? Good. I hope you understand to this. So we are good to go. Okay, good. Now the next one, important formula you need to take note of. Once you know this formula, you are good to go in solving any question any question that comes your way in an open pipe. Now, since we have this, we can simply say formula 1, okay, that my Fn is equal to, follow me, n plus 1 multiplied by what? Frequency, multiplied by velocity divided by 2L. Have you understood? Good. Now, I also have that my Fn is equal to n plus 1, okay, multiplied by fundamental frequency. Now, when and where can you use this formula? This is when you have velocity in a question, and this is when you have the fundamental frequency in a question, and they ask you to get the frequency, the normal frequency of it. Take note, good. Take note, there is difference between frequency and fundamental frequency. Don't go do the mistake of using fundamental frequency in place of frequency. They are not the same thing. It's like saying, okay, wavelength is the same thing as number of wavelength. It's not, like, they are not the same thing. Okay, because I have given you the definition of what fundamental frequency is all about, and don't go and make the mistake of misusing two of them. Okay, good. Now, do you know I can also write this formula now as, or I can also write this formula by saying that Fn is equal to HV over what? 2L. And I can also say that this formula can also be written as what? Fn is equal to what? HFO. Relax, let me explain. Okay, good. I'm going to explain something very, very important. Let me wipe this place off, okay? Let me wipe this. Okay, so I said that this is equivalent to this, or this is equivalent to this. Now, let me explain, okay? Good. Let me explain. Remember, in an open pipe, before I explain, let me give you something. Point worthy of note. Point worthy of note. Of note. In an open pipe, okay, 0/2 is equal to what? Where is that over 2? First harmonic. And first harmonic is like saying that what? F degree. Okay? 1/2 is like saying that what? Second harmonic. And is what? 2 fundamental frequency. You have 2/2 is equivalent to what? 2/2 is equivalent to third harmonic. Listen, okay? Is equivalent to third harmonic, which is equal to what? Third fundamental frequency. You have 3/2 is equal to fourth harmonic, which is what? Fourth. You already know how we got this now from the harmonic. Harmonic is equivalent to this, and /2 is equivalent to the next higher level of it, and so on. Okay, I just decided to write this out so I can be able to use this to do what? Support this my proof that is here. Okay, but before that, let me give you the value of all these things. F is the nth of the what? Frequency. I said frequency, I did not say fundamental frequency. My n is the number of over 2. My n is the number of over 2. My v is the speed of the sound. My L is the length of the pipe. My H, this guy is here, is what? Harmonic number. I decided to write it as H. In some book, you will see N. But instead of me to use NN, it will be confusing now. So I decided to use what? H. So you can understand what I'm trying to explain. Good. Any other thing? This is the fundamental frequency. This is my lambda. My lambda is always in meter. Now, I want to support this. Okay, imagine that we are asked to get the frequency. We are being asked to get the frequency of the, let me say, the frequency of the 0/2. Yes. And my velocity, we are just making an assumption. And my velocity is what? My velocity, let me use red so you notice the velocity down. And by velocity, let me say my velocity is equal to 30 meters per second. Remember, I'm just making an assumption because we are going to solve questions. So I want to prove this, okay? Now, since we have been asked to get for 0/2, first, let me make use of this formula. Using that Fn is equal to, what do I say? That my n is what? my n is the number of overtone, and for 0 over 2 is equal to saying that they have already given me overtone number, and 0 plus 1, okay, then multiply by what? My 30 divided by 2. Let me say that our length is equal to, let me say my length is 4, okay, 4 meter, and my length is what? Times 4. So it's like saying that 30 divided by 30, because this is already 1, 30 divided by 8. So divide, okay, let me get a calculator. So 30 divided by 8 will give me what? 3.75. This will give me what? 3.75, which is 3.75 hertz, because we just calculated for frequency. Okay, good. Now using this formula to support this, I can equally say that Fn is equal to, let me use red this time around, okay, Fn is equal to, my h is the harmonic number. Now look here, look, they said 0 over 2. Now 0 over 2 in its harmonic is what? Is 1. Okay, in its harmonic is what? 1. So I can say that my harmonic number is what? 1 times 30 divided by 2 times 4, and it's giving me what? 30 over 8. And if you divide, you still have the same answer. Do you understand? Good. So that is why I say that this is also equivalent to this. Okay, good. Now in an open pipe, we are still in an open pipe. In an open pipe, we have this formula that wavelength, for you to calculate the wavelength of an open pipe, you can simply say it, formula 3, okay? We can simply say that wavelength is equal to, now this is the 3. You don't need to cram this formula, okay? You don't need to cram it. Let me give you the short methods to quickly remember it. Do you know that once you know these two formulas, you can easily calculate for the wavelength of an open pipe? Now what am I trying to say? Look, follow me. If you want to get the formula for a wavelength, from here you can actually get it. Okay? Now look at what I'm going to do. I'm going to get this as my numerator, which is what? 2L divided by n plus 1. I'll now remove what? I'll now remove velocity. Okay, good. This is actually very, very simple. You collect 2L and put it on the numerator, and collect n plus 1 and put it into the denominator. Okay, from here you already know what you can do here. Now getting this is like saying that f lambda n is equal to 2L over what? Over h. And when you calculate, you are still going to have the same formula with this. Okay, good. So let me explain this. Okay, let me explain it how I explain this formula, so you can get that they are actually the same thing. Okay, let me wipe this place. All right, so we are back. Now I said let me explain this. Okay, now imagine that you have been asked to get a wavelength, and getting a wavelength, and they said that you overtune of the you have been asked to get the wavelength. Okay, and your overtune number is given as 3. Let me use 3 this time around. I've used 0. The overtune number is 3. Let me use 3. Okay, then we should get the wavelength, where our length is also 4 meters. So our length is 4 meters. Okay, our n, which is the overtune number, is what? As I said, it's 3, which is 3. So using this first, that wavelength is equal to 2 times 4 divided by 3 plus 1, which is what? Saying that 8 over what? 4. And my wavelength is what? 2 meters. Do you understand? Now using this formula also, that my wavelength is equal to 2 times 4 divided by my harmonic number is here is what? 3/2 is equivalent to 4. It's like saying is what? 4, which is equivalent to what? 8/4, which is equal to 2 meters. Do you understand? Good. So you can see that both of them are the same thing. Okay, anyone that you choose to do what to know, you know it very very well. But before you can be able to use this formula, you know the overtone. That is why I take my time to explain overtone and harmonic before we dive into this. Okay, good. Now let's try this before we move into an open a closed pipe. So imagine I have a pipe. I have this. Okay, I have this. I want to explain something. So you have in an open pipe, this is an open pipe. Okay, good. And this is my length. This is my length. So now, how many loop do we have here? Let's count together. But before that, remember that this is your what? Antinode. This is your node. This is your antinode. This is your node, and this is what? Your antinode. Okay, good. And in an open pipe, before that, let me leave it, okay, because I'm going to explain it. Okay, good. So from here, they now ask you, how many loop do we have here? Let's count. 1, 2, 3, 4. Okay, so we have how many? 1, 2, 3, 4. So our L is equal to what? Lambda is like saying that 4 lambda over what? Over 2. Okay, good. Do you understand? Do you know how we got this? Because we simply say that L is equal to lambda over 2 from what I just explained here. Good. So let's move. Now take note that length, the number of loop that you have, is equivalent to the number of what? Over 2. Now imagine that I have how many over 2 here? I have 4. So 4 is like saying that what? My harmonic is going to be what? 5. Do you understand? Now let me explain something. Let me explain that thing I want to explain. Antinode, 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 antinode. Okay, good. Get the length easily. You can just do 1, 2, 3, 4 to get it easily. And I say that length is equivalent, the number of loop is equivalent to the number over 2. Okay, is equivalent to what? Number over 2. Now they can also draw it like this. They can also draw it like this and say, okay, they can draw it like this. Okay, they can draw it like this. So when you see it, don't be surprised, they are still the same thing. So they are still the same thing. Okay, good. So this is my what? Antinode, this is my node, and this is what? My antinode. It's like saying 1, 2, 3. Okay, 3. And it's what? 3 lambda over what? Over 2. Do you understand? Do you understand what I just explained? Good. So all these are still the same thing. Now the next one we are going to be looking into is closed pipe. Okay, is closed pipe. What did I just explain? I said closed pipe. This is what? Antinode. Oh. This is what? Antinode. This is antinode. This is node. This is node. Remember I explained that node is a point of node displacement. So don't get it confusing when you want to solve questions. Okay, so now let's look into closed pipe. Let's talk about closed loop, closed pipe. Okay, closed pipe. Now when you talk about closed pipe, point 1, closed pipe is a pipe where the the one end is closed and the other end is open. One end is closed, and the other end is opened. Okay, good. Now the closed end is called the node, which is given as what? Lambda over 2. Okay, good. And the open end is what? Antinode, which is what? Lambda over 4. Good. I hope you understand to this part. Good. Now, before I support this with a diagram, I want us to take note of one important thing. Okay, good. 3, right. The harmonics are in odd multiples. This is when you talk about a closed pipe. Allow these points to stick into your memory. This is very, very important. Odd multiples. Now, what am I trying to explain? Now, they said odd harmonics, and we already know what is odd. Numbers that are odd: 1, 3, 5, 7, and so on. Now, imagine that I have 0 over 2. 0 over 2. My harmonic is going to be what? Remember, odd is going to be what? 1. 1 what? 1 harmonic, which is equivalent to what? The fundamental frequency. So I have, the next one is going to be what? 1 over 2. 1 over 2 is equivalent to what? Remember that over 2 is the highest level, but now they are talking about that this harmonic is going to be odd multiples. So my odd is going to be what? The next number is going to be 3, which is equivalent to what? Which is equivalent to 4, which is equivalent to 3 fundamental frequency. Okay, because I explained harmonics, that when you have 1 harmonics is equivalent to a fundamental frequency. I have 2 is equivalent to what? Second fundamental frequency. Now I have 2 over 2. My 2 over 2 is going to be what? 5. So I have 3 over 2. This is very, very important. You take note of it, because when we start solving questions, you are going to see everything for yourself. The next one is going to be what? 7, and it's going to be what? 7 fundamental frequency. Fourth is going to be 9 harmonic, which is equivalent to what? 9th fundamental frequency, and so on. Okay, good. Now, this is a typical diagram of what I'm trying to explain now. Remember, odd multiples. Odd multiples. Now, I have a diagram like this. I have a diagram. Okay? One end is closed. I'm trying to use it to derive a formula now. Okay? I'm trying to use it to derive a formula. Or let me just derive a formula first. Okay? Good. One end is closed and one end is open. This is an example of the first member of it. Okay? Good. So, this is my node, and this is my antinode, and this is my length. Okay? You can see that this place is closed and this place is open. Good. Now, in a closed pipe, we say that our fundamental frequency is equal to, listen, pay maximum attention, V over what? 4L. Now let's prove. Okay, good. So my L is equal to this antinode now. So this is not up to a full loop. A full loop is like saying that it is like this. Okay, it's like this. A full loop is like saying that it's like this. Okay, let me explain this very well. A full loop is like saying that we have this. A full loop. Okay, good. This is like saying a full loop. And if I represent it on a diagram, if I put it on a waveform, you will notice that this is my what? This is my crest and this is my trough. Okay, and this is a wavelength, a full wavelength. This is what I'm trying to explain. Do you understand? Good. Now let's move. So this is just like saying it is half. Okay, it's like saying it is half. It's like saying, okay, this is the half of it. So for me to get the half, it's like saying that the half of this is what? Lambda over 4. Okay, so it is going to be what? Lambda over 4. And this is what? Equation 1. Now equation 2, remember we have that V is equal to F lambda. Okay, good. And F is equal to fundamental frequency, but both of them are not the same thing. So I can simply say that is equal to velocity over lambda, and my lambda V over, listen, okay, good, listen, my lambda is what? My lambda, where's my lambda? Is equal to 4L, because if I make this the subject of formula, it's like saying that my lambda is equal to 4L. Okay, good. Now if I make this the subject of formula in which I have made, my lambda is now going to be what? Equal to 4L, and my F degree, my fundamental frequency is what? V over 4L, which is equivalent to this. Do you understand? Good. And you already know why I just explained about fundamental frequency when we are talking about an open pipe. Okay, because now we are dealing with a closed pipe. Now in a closed pipe, pay attention, in a closed pipe we have these formulas that you need to take note of, that Fn is equal to, listen, that Fn is equal to 2n plus 1 over 4L. The other one is 2L. This one is going to be what? 4L. Okay, good. Or we can say that's equal to HV over 4L. Formula 1. Now formula 2, we can say that Fn is equal to 2n plus 1 into brackets fundamental frequency, or we can say that is what? 2, that is what? H times fundamental frequency. Do you understand? H is like removing this and putting this, okay? Times fundamental frequency is still the same thing. Now for you to calculate for the wavelength of a closed pipe, remember what I explained? It's like bringing this up and putting this down, which is what? V over what? Over 4L. Okay, no, V, we have V here, okay, and this is going to be what? 4L. Or we can also say that what? 4L over H. Both of them are still the same thing. Okay, no, it's not V, it's not V. This is what? Into bracket 2n plus 1. Do you understand? It's like removing this V that is here. Okay, removing this V and say bring this down and carry this up. 4L over 2n plus 1 or 4L over H. Okay, good. Now once you know these things, you are good to go in solving questions under open pipe and closed pipe. But take note of the diagram I explained. take note of loop that I explained. That loop can be in two forms. Loop can be in two forms. Either you have this form, either you have this form. Okay, either you have this form or you have this form. They are the same thing. So we are going to start by solving questions. I have a whole lot of questions that we need to solve under this, so you can properly understand every single formula that I've given to you. Okay, so we start by solving question 1. Okay, now let's solve questions. Okay, good. Let's solve question. But before we start by solving questions, I want us to take note of these formulas again. I'm going to be writing it here, so when we start solving question, we will be referring there. Now we have that in an open pipe. Okay, opened pipe, we have that Fn is equal to bracket n plus 1 over 2L, or I can simply say that is equal to HV over 2L. Open pipe. Okay, so we also have that Fn is equal to n plus 1 fundamental frequency, or HV multiplied by fundamental frequency. So we also have wavelength is equal to 2L over bracket n plus 1, or 2L over what? Over H. Now in a closed pipe, Fn is equal to 2n plus 1 V over 4L, or HV over what? 4L. I can also say that Fn is equal to, listen, is equal to what? Look here, 2n plus 1, or what? Can simply say it is what? H fundamental frequency. Okay, good. Now in wavelength, we have it at 2, which is what? In wavelength 4L. Let me remove this bracket. We are talking about wavelength 4L over 2n plus 1, or I can simply say that is what? 4L over what? Over H. Now once you know this formula, you are good to go in any question that we are about to solve now. Okay, good. Now let's start by solving question 1. Okay, so the question says, if the fundamental frequency of a closed pipe organ on a day when the speed of sound is 640 meters per second and is also having a frequency of 160 Hz, then the length of the pipe is what? Now they said organ. Okay, they said organ. Now are we going to classify it under an open pipe or a closed pipe? Now I want us to take note of this. Organ, how can we know if it is a closed pipe or is an open pipe? So let's take note of this. Organ is under a closed pipe. Okay, organ is under a closed pipe. When you hear sonometer, is what? Because the two ends are bonded with strings, it is what? An open pipe. Okay, good. Now question 1, remember they said the fundamental frequency. Now when they said fundamental frequency, remember I taught you that harmonics, okay, harmonics of a fundamental frequency is like saying, where is it? Fundamental frequency. So our overtuned here is going to be what? 0. Do you understand? Good. Now why am I trying to explain that our overtune is going to be 0? Let's write out the parameters first before we start identifying how the question is. Now the first one, we have that our velocity v is 640 meter per second. Okay, our frequency is equal to 160 hertz. You can see that there is difference between frequency and fundamental frequency. Then length of the pipe, we are looking for it, unknown. Then they now said fundamental frequency. You know that from this you can use it to get your number of overtone and your harmonic. Now listen, when I was explaining harmonic, I said that the first harmonic is equivalent to what? Is equivalent to the fundamental frequency. Okay, good. And when I was explaining overtone, I said that overtone, 0/2 is like saying what? 1. Okay, it's like saying what? 1 harmonic, because it's the next higher level of this. So now let's solve. Using this formula, folks, I have that Fn is equal to, where's that formula for closed pipe? 2n plus 1 over 4l times v. Okay, good. Now Fn is going to be what? 160 is equal to, listen, my overtone is what? 0, because it's the first fundamental. Go and take that thing that I have wiped out. You copy it. I hope you copied it. So as I'm solving, you'll be referring to that book. Okay, so overtone of a fundamental frequency is 0. So 0 times 2 is like saying it was 0, and is equivalent to say 1 times my frequency, my velocity is what? 640 divided by 4l. Okay, good. And it's like saying that 160 times 4l. Okay, 160 times 4l. Calculate fast. 160 times 4l is going to give me what? It's going to give me 640l, which is equal to 640. And from here, my L is what? 1 meter. We have used formula 1. Now using formula 2, when we say that Fn is equal to hv over 4l. Now Fn is equal to, now pay maximum attention, since my overtone is 0, my harmonic is going to be what? 1. So 1 times 640, okay, divided by 4l, and this is like saying that we have it to be what? 160, and my L is equal to 640 sorry, divided by 160 times 4, which is equivalent to 1 meter. Okay, good. And this is your final answer. So any formula that you choose to use to solve, you are still going to arrive at our answer. But the first thing that you need to know is, number 1, you know that harmonic. I explained harmonic, that the one harmonic is equivalent to the first fundamental frequency. The second harmonic is equal to the second fundamental frequency. Now when you talk about overtone is talking about the next higher level. Now imagine I have 0 overtone. The next overtone is going to be what? The next harmonic is going to be what? 1 harmonic. Okay, and it's equivalent to what? The fundamental frequency. So imagine I have 1 overtone is going to be what? 2 harmonic, higher level. After 1 you get 2. Okay, after 2 you get 3. That's what I'm trying to explain. So an option, what is correct? So we have option D to be correct. Now let's solve question 2. Okay, good. Now question 2 says the second overtone of a closed organ pipe of a closed, you can see organ. When you hear the word organ, they are talking about a closed pipe. So you don't need to worry yourself about the English, the grammar there. A closed organ pipe has a frequency of 450 Hz what is the length of the pipe if the speed of sound is 330 meters per second. Okay, good. Now our velocity, okay, our velocity here is what? So we have our velocity to be speed of sound 330 meters per second. Then we have our frequency to be 450 Hz. And our L, we are being asked to get for it. But they mention second over 2. Okay, good. They mention second over 2. Now, since we are dealing with a closed pipe, I wanted to explain that in here, but let me just explain it using this question. Since we are dealing with a closed pipe, okay, remember that I said that harmonics are multiples. All right, good. Now, since my over 2 is what? Is 2, according to the question, second over 2. So it basically means that my 0 over 2 is what? 1. My first over 2 is going to be what? 3. My second over 2 is going to be 5. Multiples of harmonics, which is odd. Now from here, okay, using also this formula, my 450 is equal to, pay maximum attention, 2 times 4 plus 1. N is the number of harmonics. I'm going to use this formula also and solve. Okay, so when we solve up to 3 questions or 4, I'll stop using 2 of them. But now I want you to fully understand what I'm trying to do. Plus 1 times my V is what? 330 divided by 4L. Okay, good. So this is like saying that 450 is equal to 5, 4 times, is it 4 times 2? No, this is 2. Okay, because my over 2 is 2, so it's 2. So 2 times 2 is 4, which is 5 times 330 divided by 4L. Okay, good. So the next thing is like saying that therefore 4L times 450 is equal to 5 times 330. Okay, 5 times 330 is 1650, and my L is equal to 1650 divided by, multiply this, 4 times 450 is 1800. Okay, and let's divide 1650 divided by 1800 is going to give me what? 0.917. L is equal to 0.917 meter. Okay, good. Now in the question, our option is in centimeter, so converting L to centimeter is like saying 91.7 centimeter. Now using this formula, okay, good. I don't have enough space again. Let me use my hand and clean this because we still wipe this off. Okay, good. Let me get blue. Okay, I have blue here. So now I have that F is what? 450, right? Is equal to my harmonic. Now what is going to be my harmonic? Since they say second over 2. Second over 2 is going to be what? 5 harmonic. So 5 times 330 divided by what? 4L. And when you substitute everything, you are going to get your length to be what? 91.7 centimeter. You can see that these two formulas are the same thing. And option what is correct? Option D is correct. So we have solved only 2 questions. I've used these 2 formulas to explain how to use them. So let's solve question 3. Question 3 says, this is a theoretical question. What is the unit for measuring the amplitude of a sound? Option A, cycles. Option D, decibel. Option C, flux. Option D is coulombs. So if you are about to, even though that you don't know the answer, even though they don't know the answer, you can simply get the answer to this question easily. Now let me give you a trick. You already know that cycles is not meant for amplitude, because amplitude of a wavelength is always in meter. That one is wrong. Flux, we are not talking about magnetic field. Coulombs, we are not talking about electricity. So the correct answer is what? Option B, decibel. Okay, good. Now question 4. Question 4 says the diagram above shows a stationary wave of a wavelength 40 centimeter in a closed tube. The length of the resonating air column is what? Now let me explain something. Take note that progressive wave can also be called traveling wave, and standing wave can also be called a stationary wave. Okay, you know, when you say that something is stationary, something that is not moving. When you say something is progressive, something that is moving, from the word progress. Okay, good. Now let's start by solving question 4. And even this question 4, I've even solved it. I did not even know that my video was not recording. Okay, now question 4, we need to solve it. Okay, so now solving this question 4, we first and interpret the diagram. Okay, let's first and interpret the diagram. Now interpreting the diagram, we have it that 4, question 4, we have the pipe like this. More if you see the kind of thing that I've explained, this number 4, but as well. Okay, all I need from you, just listen now. So this is it, and this length, and this length. Okay, good. Now in this question, we are being asked to get the length of it. So remember that this is a what? This is a closed pipe, because this is closed and this is open. It's like saying that this is my node, this is anode, this is node, this node, and this anode. Okay, good. So L is equal to lambda over 4 in a closed pipe. I've explained all these things. Okay, good. Now how many lambda we have in here? 1, 2, 3. So it's like saying that we have what? L is equal to 3 lambda over 4. Okay, good. Now we already know that we are being asked to calculate for the what? For the wavelength, for the length. Okay, so when you see that L is equal to 3 times 40 divided by 4, and our length is equal to what? 3 times 40 divided by 4, you have it to be 30 cm. I think this my light is disturbing, but pay maximum attention. Okay, so now let's move. So we have 30 cm, and this is the final answer. But let me explain one more important thing. When I was explaining opened pipe and closed pipe, I made a mistake somewhere. So the mistake was, I said that this number of loops, I call it overtone. It's not overtone. This number of these lines, this number of loops, 1, 2, 3, we can also say it's equivalent to the what? To the harmonics. Okay, so here we are having that our harmonics is what? Harmonics is 3, and since it is in a closed pipe, we say that the harmonics are in multiples, odd multiples. Now our overtone here in this particular question is going to be what? So since 0 overtone is 1, then 2 overtone is going to be what? 3 harmonics. So our overtone here is what? 2. Be referring to that particular node that I give you. Okay, now using the normal formula for calculating wavelength, I can choose to use wavelength is equal to 4L over what? Over H. Okay, or I can also choose to use 4L over what? 2 n plus 1. So let's use 1, okay? So this is equivalent to say 40, or yes, 40 is equal to 4L over my harmonics is what? 3. And it's like saying that 40 times 3 divided by what? 4. And when you solve, you still have 30 cm. If you also use this formula by putting your what? Your harmonics, okay? By putting your, where's the harmonics? By putting my harmonics, this is 1. My harmonics is 1, not 2. Then if I put my harmonics here, which is 1, then 2 times 1 is 2 plus 1. Now, do you know why I say that my harmonics is 1, not 2? Because 0 over 2, no, my over 2, sorry, is 1. My harmonics is 3. So my over 2 is like saying 0 over 2 is equal to 1 harmonic. Then 1 over 2 is equal to 3 harmonics, because we are counting it in odd multiples. So I made a mistake. This is number of overtone, which is 1, and my harmonics is 3. So the final answer is what? 30 cm. And the correct answer to this question is what? Option D, 30 cm. Okay, even though, remember that I also said that node is lambda over 2. Then antinode is lambda over 4. Now, since this is a full loop, it's like saying lambda over 2 plus lambda over 4. If you do it, it's still going to give you 3 lambda over 4. Okay, do the maths yourself. You see everything I'm trying to explain. So now, question 5. Question 5 says a closed organ pipe and open organ pipe emits notes of the same pitch. The ratio of the length of the air column in the closed pipe to that of the air column in the closed pipe to that of the open pipe is what? Okay, good. Now let me check if this is recording. All right, so it's recording. So basically we have been asked to get the ratio. So they did not mention anything like fundamental, they did not mention anything like the overtones. So what we are basically using, we are using the fundamental frequency formula to compare both the closed and the open. So in this question they said a closed organ pipe. So closed will be what? Closed will be fixed. So in closed, we have it to be, remember, or I've cleaned those formulas, we're supposed to be referring to that point. Okay, so this is like saying that we have it to be, I'm going to be using HV, okay, over 4L, which is the first one, which is closed, is equal to HV over 2L. So this is like saying that this will cancel out this, and we have that this will cancel out this, and it's like saying that, but okay, let me not cancel out now. Okay, V, okay, let's leave it like this. It's like saying that therefore HV into brackets 2L is equal to HV into brackets 4L. Okay, so this will now cancel out. So it's now like saying that L is equal to 2 over what? 4, and is equal to 1 over 2, and it's like saying that is equal to 1:2. And this is your final answer, and option C is correct. So now let's solve question 6. If you use the other formula, that says that, let me get blue. If you use the other formula that says that, Fn is equal to 2n plus 1 V over 4L. This one is for close, and for open, you just remove this by saying that Fn is equal to n plus 1 V over 2L. Even though you use this formula, you are still going to arrive at this. Try it out, okay? Good. Now let's solve question 6. So question 6 says, find the frequencies of the first 3 harmonics of a piano string at strings of length 1.5 Okay, 1.5 meter if the velocity of the wave on the strings is 120 meter per second. Now we are being asked to get for the what? For the Fox 3 harmonics. And when I was explaining harmonics, I said that it is the frequency that are multiples of the fundamental frequencies. Okay, so it's like saying that my harmonics, Fox harmonic, is going to be what? Having a frequency of this. My second harmonic is going to be having a frequency of this. Okay, my third harmonic is going to be having a frequency of this. Okay, good. Now when it comes to overtone is now the next higher level. Now the next higher level is like saying that 0 overtone, which is OV, is equal to 1 harmonic. Now 1/2 is saying that it's going to be what? 2 harmonic, and 2/2 is going to be what? This over 2. Okay, it's going to be what? 3 harmonic. So we are done with what we want to know. Okay, now you mean using which formula should I use? Let me use the simplex one. Okay, so HV divided by 2L. So using for the first, I'm going to name it A. So the first is saying that our harmonics is what? 1. So 1 times our velocity is here 120 divided by 4L. Okay, divided by 2L, sorry, not 4L. Now let me explain something. This question is talking about piano. Now when you talk about piano is having an opened end pipe. Is an open end pipe instrument. Why? Because strings are being connected end to end. Okay, strings are being connected end to end. It's like saying that opened is like this. Okay, there is string here, there is string here. Do you understand? So I've given you that organ is a closed. Sonometer is an open. Is an open organ. Okay, good. Now it's going to be 2 times 1.5 because my length is 1.5 according to the question. So this is 120 divided by this 3 and divide 3 into this is 4, so it's what? 40 hertz. You do also for B, which is the second one, by saying 2 times 240 divided by this is already 3, and this will give me 480. Yes, 480 divided by 3. No, 2 times 240, 480 divided by what? Okay, good. Okay, 120. This is 120, so it's going to give me 240 divided by 3. 240 divided by 3, which is what? 80 hertz. So you also do for C, which is 3 times 120 divided by what? 3, and it's going to give you what? 120 times 3, 360 divided by 3, which is what? 120 hertz. And this is the first one, this is the second one, and this is what? The third one. Okay, so it basically means that we have 40 as the first, 80 as the second, and 120 as the third. So looking into the question, we have it that option B is correct. Here we have 40 hertz, 80 hertz, and 120 hertz. So option C is correct. Okay, no, option B is correct. Okay, now let's solve question 7. Let's solve question 7. Okay, good. Now question 7 says an open pipe closed at one end produces its first fundamental note if the velocity of the sound in air is V and length is L. Then the frequency of the note is what? So they said an open pipe closed at one end. An open pipe closed at one end. They are talking about what? A closed pipe. And a closed pipe is being given out because they asked us to give the frequency of the note, which is F. F is equal to what? F. Okay, F is given as what? HV, sorry, divided by what? 4L. Okay, now in this question they said the first fundamental note. Okay, now the first fundamental note of a closed pipe is what? Where is it? The first fundamental note of a closed pipe is like saying that it is what? It is 0 overtone. Our overtone is 0 and our harmonics is 1. Now, what am I trying to say? Remember this, that 0 overtone is equivalent to 1 harmonic. Okay? Then 1 overtone is equivalent to 3 harmonics. Because why? In closed, they are in odd multiples. So we are counting it what? Odd multiples. Now, since this is equal to since 0 overtone is equal to 1 harmonics, we can also say that 1 harmonics is equal to the fundamental frequency. Okay? Now, the fundamental frequency is like saying, since they say that our fundamental frequency is what? Is our fundamental frequency note. So our harmonics is going to be what? 1. Okay? Times V divided by 4. And our length is also L. So it's like saying that V over 4L. And this is your final answer. You can also use the other formula that says that Fn is equal to 2n plus 1 times V divided by 4L. Now, your overtone here is going to be what? 0. Okay? Your overtone is going to be what? 0. And option A is correct. So now let's look into question 8. Okay? Let's look into question 8. Now question 8 says, if a sonometer has a fundamental frequency of 450 Hz, what is the frequency of the fifth overtone? What is the fifth frequency of the what? Of the overtone. Now, basically here, we have that fundamental frequency is what? Fundamental frequency is what? Is 450 Hz. And we are being asked to get the frequency, the normal frequency. These two things are not the same thing. Now, which formula are we going to be using? That F, okay, is equal to H what? HV. And this is equivalent like saying that our H here is what? Since they said fifth harmonic, okay? Since they said fifth harmonic, and I said that sonometer is an open pipe, okay? Sonometer is an open pipe. Now, since they said fifth harmonic, so say fifth overtone, sorry, fifth overtone. Now my fifth overtone is like saying that fifth overtone is equivalent to what? Sixth harmonic. Okay? Because overtone is the next higher level. So imagine that I have fifth overtone. The next higher level number is going to be what? 6. So that is my what? My harmonic, which is what? 6. Okay? Times 6 times what? 6 times 450. So let's multiply. 6 times 450 is giving me what? 2,700 Hz. Okay? Good. Now, if I choose to say, okay, that Dx is equal to n plus 1 times my fundamental frequency, this is n. Now, the question, they already gave us what? The overtone. It's like saying that 5 plus 1 times what? Times 450. And when you multiply, you still have 2,700 Hz. Okay? Good. And option 1 is correct. Option A is correct. Now, let's solve question 9. Okay? Good. Let's solve question 9. Now, question 9 says, the wavelength of the first overtone of a note in a closed pipe of length 33 centimeters is what? Remember, they said the wavelength of the first overtone of a note in a closed pipe. Now, wavelength is like saying that what? 4L over H. I'm going to use this, or I can simply say that it is what? 4L over 2n plus 1. Okay, good. Now my harmonics, yes, since they said first overtone. Now first overtone is going to be what? 3. First overtone, my harmonics is going to be what? 3. Since 0 is 1, okay, 1 is going to be 3. Since they are coming down from what? They are coming down from what? They are coming down, for example, from 0. The next number I will get is what? 3, since they are odd multiples. So it's like saying that my what? My wavelength here is what? Because we have been asked, they say the wave of a first overtone of a closed pipe in a closed pipe of length. So we have been asked to get the wavelength. So it's equivalent to what? 4 times, my length here is what? 33. My harmonics is going to be 3. So 4 times 33. 4 times 33 divided by 3 is going to give me 44 cm. Now if I choose to use this formula, it's like saying that 4 times 33, okay, divided by 2 times, my overtone is going to be what? 0. Okay, good. Do you understand what I'm trying to explain? Now listen, my overtone is going to be what? 1, not 0. It's true, my overtone is going to be 1. Why? Because 0 over 2 is 1 harmonic. Then 1 over 2 is 3 harmonics. So it's going to be what? 1 plus 1. And this is like saying that 4 times 33 over what? Over 3. And when you divide, you still have 44 centimeter. And this is your final answer. Okay? And we have it that option B is correct. Okay? Option B is correct. Now let's solve question 10. I think this is the last question. And I'll give you one as an assignment. I'll give you one as an assignment now. Okay. This question says a string is being fastened tightly between 2 walls. Fastened tightly between 2 walls. 2 walls. You already know what is it. A what? An open pipe. Now, they have been attached between 2 walls. Then the wavelength of the second overtone. The wavelength of the second overtone is what? Now let's solve together. Okay, good. So now solving together, we have been asked to get the wavelength. And for wavelength of an open pipe, we use this. Is equal to 2L over H. Okay, good. Now 2 times, my length there is what? 24. Divided by my harmonics is what? Since they are saying that, listen, pay maximum attention. Since they are saying that it is second overtone, my harmonics is going to be what? 3. Do you understand? Since they are saying that it is second overtone, after 2 you get 3. Okay, it's going to be what? 3. So 24 times 2 divided by 3. So I have it to be what? 16 centimeter. Or I can use this formula also. I can choose to use this formula. Okay, where's that formula? Okay, let me clean here. I can also choose to use this formula that said wavelength is equal to 2L over n plus 1. Now my number of harmonics is going to be what? Since 0 harmonics is equivalent to what? 1 harmonics. 0 over 2, sorry, is equivalent to 1 harmonics. Then 1 over 2 is equivalent to what? 2 harmonics. Then is equivalent to 2 harmonics. Okay, then 2 over 2 is equivalent to 3 harmonics. Now it's going to be what? My 2 times 24 divided by 2 plus 1, and is equivalent by saying 24 into this is 48 divided by what? 3. And if you divide, you still have this. Okay, good. And we have it that option C is correct. Okay, so I've explained every single thing that you need to know under these sound waves. Okay, and I'll give you some assignments to do. The question will be in the comment box. Do well to do it and drop your answer. I explained every single thing that you need to know. You take note of the correction that I made about this. That when you have a loop, Okay, this can also represent the number of harmonics, not number over 2. Do you understand? So I hope you really enjoyed this video, and if you do well. If you have not subscribed, do well to subscribe to our YouTube channel, like this video, share it out to your friends so they can also benefit. Alright, I still remain Noble. See you, I'm founder of Noble Tips. So see you in the next video. Bye.